All right, welcome to section 4.2. The intent is to make 4 separate videos in this section. Hopefully we'll be able to keep them a little on the short side. This is a fairly lengthy section. This section is all about exponentials. Remember the last section we dealt with inverses? And inverses are what I like to call the undo buttons of each other. So an exponential is going to undo a logarithm, which is what we're going to talk about in section 4.3. Logarithms undo exponentials. All right, let's look first of all at some properties of exponentials. The first thing that I want to point out to you is that somehow my computer used a wrong symbol here. So my not equal symbol somehow disappeared and it was replaced with a 1. So make sure you fix that. A does not equal 1. And then the other part of that is that A is going to be a positive number. If A is positive and A if does not equal the number 1, then the following statements are going to hold true. The first statement is that A raised to the x power, notice there that my variable is now in the power, in the exponent. A raised to the x power is a real unique number, a unique real number, excuse me. We can write this in 2 different ways. We can say that y is equal to a to the x power, but it can also be considered a function, which is f of x equals a to the x power with a domain of all real numbers. This next rule, property B, is one of the most important properties you're going to see in this section, and we're not only going to use it several times in this section, we'll use it later on in chapter 4 as well. So make sure that you take some effort to understand property B. Property B says that if A raised to some B power is equal to the same base A raised to C power, then what's going to happen is we're going to know that power B is equal to power C. The way I like to word this usually is if my bases are equal, then my powers must be equal. And the reverse is also true. If my powers are equal, then my bases must be equal. This is another way of saying that my function is 1-to-1, but property number 3 is quite important. Or property letter B, excuse me. Property letter C says that if my base A is greater than 1, and if my power M is less than my power N, then A raised to the mth power has to be less than A raised to the nth power. Now, an example of this, notice across the page there is 2 cubed is less than 2 to the 4th. Now, we understand that concept, and that's all property C is saying. A is greater than 1. My base is 2 here, so that's a greater than 1. My power 3 is less than my power 4, so therefore 2 cubed has to be less than 2 to the 4th power. Another way to say this in English is that when I increase my power, this is going to lead to a greater number. So we can say that 2 to the x power is an increasing function. Now, property D is the reverse of that. So, or not the reverse, but slightly different. This time, instead of A being greater than 1, my A value is between 0 and 1. And you can see here that my base is a 1/2. And but my powers have the same requirements. My power M is less than my power N. And if this happens, then A raised to the mth power is greater than A raised to the nth power. Now, when you look at the example, we know that 1/2 squared is a 4th, and 1/2 cubed is 1/8. And I think we understand enough about fractions to know that a quarter, a 4th, is greater than 1/8. If you eat a quarter of a pizza, you have eaten a good bit more than if you just eat an 1/8 of a pizza. So we say that when I increase the exponent here, this is going to lead to a lesser number, and my function is going to be a decreasing function. Throughout this section, I'm going to be reminding you of rules that you have had in past math classes, things that you should remember, but you might not. So I'm just going to remind you of these. So part E here, property E, says that if I have a raised to a negative power, this is going to equal 1 over a to the positive m power. And the way I like to word this in English is negative powers allow you to move from top to bottom or from bottom to top. I want to point out that my bases are the same base. That didn't change. The only thing that's changed is that my power has changed signs. So changing the sign on your power causes it to move from top to bottom or from bottom to top. The last property here that I'm going to remind you of on this first page is a fraction power property. So you'll notice that I have an a, and I'm raising my base to the t over r power. So this is a fractional power. What you notice is that the bottom number of that fraction is going to be the root. So a fraction power can always be rewritten as a root of some sort. The bottom number tells you what kind of root it is. The top number tells you what the power is. And notice that the power can be written either on the inside of the root or on the outside of the root. Either is okay. So fraction powers are going to cause roots. The top number is the power. The bottom number is the root. All right, here we're just stating what the exponential function is. It's f of x is equal to a raised to the x power. And again, a needs to be a positive number, and it cannot equal 1. Now let's look first of all in this reflection question. Why do we have these restrictions? Well, let's assume that a does equal 1. Well, if a equals 1, then we have 1 to the first power, 1 to the second power, 1 to the third power, 1 to the ninth power, 1 to the 100th power. All of those are equal to the number 1. So if a were equal to 1, then my function would just be a constant. So that would not be an exponential function. For another restriction here, dealing with a being positive, let's assume that a is negative. And let's just choose an example here of x equaling a half, just a random example. So let's say that I choose my a to be a negative 2. All right, so negative 2 to the half power. If we go back and we use this last property that deals with fraction powers, then what we notice then is that this right here, being a fraction power, can be rewritten as a root. And so this would be written as the square root of negative 2. However, that's not a real number. So I have to have restrictions because of the fact that I might not have a real number out, or I might only have a constant number out. So that square root of a negative we know is an imaginary number, which is not real. All right, let's look at example 1. And this is going to go through four different values that we need to plug in for f of x is equal to 4 raised to the x power. Notice that it asks us for two things. Number one, it asks us for an exact solution, and secondly, it asks us for an approximate solution. All right, so let's go ahead and plug in a negative 2 first. So this is going to be 4 raised to the negative second power. Remember that rule, and I have it written right down here at the bottom of the page, that rule that says negative powers let us move from top to bottom or bottom to top. And so this is going to be the same thing then as 1 over 4 squared, which is 1 over 16. Now, the approximate version, if you take 1/16 and you put that into your calculator, this is going to be rounded to the nearest thousandth, 0.063. And the directions did say to round to the nearest thousandth. All right, part B. Let's plug in a 5 for our value of x. So we have 4 to the 5th power. Throw that into the calculator. That'll be 1024. For part C, f of 2/3 is going to be 4 raised to the 2/3 power. So let's make sure here that we use the property that I've relisted for you down here at the bottom. The bottom number tells me what the root is. The top number tells me what the power is. So we'll go ahead, and 4 squared is 16. And the cubed root of 16 can be simplified a little further. I like to think of this as the cubed root of 2 times 2 times 2 times 2. And these first 3 2's, that's the same thing as 2 cubed. So the cubed root of 2 cubed would just be a plain old 2. And then the last 2 would just stay inside of that cubed root. Now, I was asked for an approximation of this, and so an approximate, unfortunately, I did not write that down. I apologize. Let me see here if I can switch over really quickly to my calculator. Of course, I can't find it. And so if we do the cubed root, so we'll go to the math function, option number 4, the cubed root, let's try that again, of 16, and that's going to equal to 2.5198, but we were told to round to the nearest thousandth, so that'll be 2.520. 2.520. And then last but not least, we have part D, and plug in 2.15 for our x, and we can throw that into the calculator, and that'll be 19.698. All right, so this particular video then, we'll go ahead and stop this one and pick up for the next video.